Hello, today we're dealing with something called percentage yield. And firstly, what's the meaning of yield? Well, when we're talking about a chemical reaction to make a product, the yield is the actual amount of product that you get. So the yield is the amount of product that you get made in a chemical reaction. And we can also work out something called the percentage yield. And we do that by the equation that's on the screen now. So if you want to work out the percentage yield, you divide the mass of the product actually made divided by the theoretical mass of the product, times 100. Now let's have a look at an example of a chemical reaction that's quite useful. We've got calcium carbonate made to calcium oxide, which also produces carbon dioxide. The raw material is calcium carbonate and the useful material is calcium oxide. We can also call the raw material the reactant. The carbon dioxide, being a gas, would be given off to the atmosphere. Now let's have a look at a balanced formula equation for this. So we've got calcium carbonate, which is a solid, reacts to make calcium oxide, which is a solid, and our carbon dioxide gas. Now the slight issue here with this reaction is that both the calcium carbonate and the calcium oxide are white powders. They are pretty much identical to each other, if not identical, and hard to tell the difference. This reaction happens with the help of heat, and it's actually a thermal decomposition reaction. It happens in a structure called a rotary kiln. So there's a rotary kiln, just a simple diagram of one, with a little character next to it just to give us an idea of how big that thing is. But what we have is the rotary kiln. There is heat supplied at one end, and this whole thing rotates in order to mix that white powder so that all of it is heated as evenly as possible. And of course we have to put in our calcium carbonate into the kiln itself to get the reaction actually happening. Now there could be a slight problem in this reaction because we want to get as much calcium oxide as possible, but sometimes we don't always get as much of the calcium oxide as we want, and there are various reasons. Now the list of reasons I'm about to give you for not getting the amount of product that we expect is not just applicable to this reaction. It could be applicable to a whole bunch of other reactions as well. But in general, the reasons why we don't get the expected amount is because the reaction may not go to completion. So the reaction may not complete, or the reaction might be reversible, for example, when making ammonia. Also, sometimes some of the product may be lost when separating it out from the reaction mixture at the end. So if we're trying to separate it out, we might lose some of it. And also we might have some reactants reacting in unexpected ways or reacting in ways that are different to what we expected. So we get different products. So these are generally the key reasons why we get, or we might not get, the amount of product that we expect. And we have to look at the individual reaction before we decide which ones might be applicable. So in this case, we might lose some of that calcium oxide. When we are removing it, some of it might stick to the sides of the kiln. Okay, now let's have a look at an actual calculation that we might be asked to do. This is quite a straightforward one, so hopefully it shouldn't present too much difficulty. But basically we've got something called sodium carbonate that's been made in a lab. We've got a theoretical yield that's been given to us, and we've got an actual yield that's been given to us, and we're trying to work out the percentage yield from this experiment. That would simply be a case of the actual mass of the product made, which is 24, and the expected, which is 30, times 100, forgot to add that up there, times it by 100, and that gives us an answer of 68%. So our percentage yield is 68% for this question here. Now we can look at a slightly trickier example. So this would be for the higher tier because we're going to calculate the actual expected amounts from this reaction. So we have a reaction that's potassium iodide plus lead nitrate makes lead iodide and potassium nitrate. Looks all very confusing, but if we just break it down, it'd be nice and straightforward, hopefully. Here's the balanced formula equation, and very kindly, they've given us the relative formula masses calculated for us in the question. What we have to do is calculate the mass of lead iodide that's made from 664 grams of potassium iodide. Now, what I always tend to do is to put the numbers actually in the equation itself, just to make it slightly clearer. So we don't know the mass of the lead iodide, but we do know the mass of the potassium iodide, 664 grams. And because we're only dealing with those two, we can actually quite happily ignore the other substances in that equation. Now, we know from a previous video that the ratio of moles can help us with this. Now, if this doesn't make sense to you, that what we're about to do, please do go back and look at the reacting masses video, and that will tell us. But what we're going to look at is a ratio of moles of potassium iodide versus lead iodide. So we want to work out the moles of potassium iodide, and you remember, to work out moles, it's grams, or the mass, divided by the relative formula mass. So the mass for potassium iodide given in the question is 664 grams, divided by the relative formula mass given to us is 332. That includes the fact that we've got 2 moles of that in our balanced equation. And then on the other side, we don't know the mass of the lead iodide, but we do know the relative formula mass, which is given in the question. Okay, so we can treat this ratio sign as an equal sign. So 664 divided by 332 is 2. Multiply it by the 461 from the other side of the equation. And that gives us an answer of 922 grams. So the amount of lead iodide produced, in theory, that could be produced is 922. The next part of the question says that we actually only got 900 grams. What's the percentage yield? So this is slightly more straightforward now, because we're just doing a simple percent calculation. We got 900 grams, but we expected 922 from our calculation. We just worked that out on our calculator. So 900 over 922 times 100, and that will give us an answer of 97.6%. So that's our final answer there. Okay, so that's how we deal with percentage yield calculations, and also what we mean by percentage yield and reasons why we might not get the actual yield we're expecting. Okay, so that's it for this video. Thank you for watching, and see you in the next one.